Hello guys, so today we are going to solve a lead code problem, set matrix zeros. So we are given a matrix of size m cross n, and if an element is 0, then we have to set its entire row as 0 and its entire column as 0, and we have to do it in place. So let's see an example. If we have this matrix, then for this 0 we have to make its entire column as 0 and its entire row as 0. And for example 2, if we have a 0 here, then we have to make its entire column as 0 and its entire row as 0. And for this 0 as well, we have to make its entire row as 0, which is already 0, and its entire column as 0 here. So our final output would be this matrix. And make sure that we don't have to transform the matrix for the zeros that we have updated. So for this 0, we would not make this column as 0. So let's see how we can solve this problem. So if we are given a matrix, let's say 1 2 and 0 here, and 8 9 6 and 0 4 and say 6. So what we can do is, while iterating the matrix row by row, if we encounter a 0, then we can set this row as 0 and the entire column as 0. But we can see, let's mark it as 0, let's mark it as 0, mark it as 0, mark it as 0. But it introduces a new problem. That is, when we would move to the second row, then we would see this 0, and for this thing we would make this row as 0 as well, which we should not do. So to fix this problem, what we can do is we can say that this is a modified cell. We can store this cell as modified, and so when we would go to the next row, and we see that the current element is 0, and it is also modified, so we would not set its row and column as 0. So the time complexity of this solution is m cross n, where m is this size, m is the number of rows and n is the number of columns, and the space complexity is also m cross n, because we have to store the whole array to store if a cell is modified or not. So we have to reduce the space complexity. Let's see how we can do that. So suppose we had this matrix 1 2 0 and 0 6 8 10 2 and 3. So say what we can do is, so when I'm iterating through this row and I encounter a 0 here, I'm sure that I have to set this whole row as 0. So let's say just mark it as true, that we have to make this entire row as 0, and I can mark it as 0 safely. That would not harm me, right? So I can make it as 0. Now I can move to the next row, but the problem is, if I am in this row where I do not have to set it as 0, and this 3 should be 0 because of this 0. So how can I know that this 3 should be 0? The row is fine, because for every row I know that if I should make that row as 0 or not by traversing it. But what about the column? So we have to store the column somewhere. So we can take an array that would store if that column should be 0 or not. So that array initially is false. So suppose, let me just go back. So when I encounter this 0, I know that this whole column would be 0, so I can say that this column should be 0. and then after marking this column as 0, I can make it as 0, and I can also set it as 0. And then I move to the next row and I traverse this row and I see if it should be 0. So I find a 0 here, so I would mark this column as 0, that it should be 0, and then I set this whole row as 0. Okay, and then so this was true, and then I set it as 0. Then I traverse this row and then I see that this is false, this row should not be 0. So now finally what I can do is I can iterate through this whole matrix. So my matrix looks something like this: 0 0 0, it is then 0 0 0, it is 10 2 3, 10 and 2 and 3, and I have a true, false and true. So while iterating this, I can see if this column is set as 0, which is true. If this column should be set as 0, then I make it as 0, and this is false and this is 0. So this is our final answer. So the space that we used for this solution is big O of the number of columns, O of n, because this is just a variable that would tell us for every row if it should be 0. So this is O1, and for the columns we have to store the columns. So let's see how can we make it a constant time in place, how we can do it. So one thing is for sure, that if we want to do it in place, then let me just write the matrix first: 0 8 and 9. If I want, so we can know by traversing a row that if it should be 0 or not. So this should be a 0, and this row should be, let's say, just for the first iteration, because we do not want to store it, I know that this row should be set as 0. But how can I know for this column that this should be 0 or not? I have to store it somewhere, and we cannot use any extra space. So let's try to actually use the first row as the row that we want to use to store the columns if it should be 0 or not. So for a moment, what we want to do is, I would try to use the first row as the row that would store if the column should be 0 or not. Let's see. So why we are doing this? So for example, in this row there is no 0. Okay, in this row I get a 0 here, and I use this, and I use this, and I mark it as 0, and this tells me that this column should be 0 for the next rows. If it has next rows, then this whole column should be 0. And why we are using the first row, I would tell you. So let's say then I go to the here 8, then we have the, we don't change the value, and I go to 9, I don't change the value. So one thing that we can see is that our whole, we would get the correct answer for the whole matrix. The problem is for the first row, because it has been modified now. This is now modified. So let's see two cases. Suppose our first row is this 1 2 and 6. That means it has no 0 elements. Then it should be not set to 0. This row should not set to be 0, right? So this is our first row, and then in this second case our first row might contain a 0. So let's say our first row is this. So if this is the case, then we know that we do not have any problem if this has been modified, because it ultimately we have to set this entire row as 0, right? So it should be 0 0 0 at the end. But in this case we have to retrieve the original row, which is the first row. Well, let's see a case. For example, if we have a matrix, let's say we have let's say this 1 2 6, this is the first row, and we have a 0 here somewhere in the matrix, and here it is some value, and we have a 0 here, and we have some values here. So this 0 would change this 1 to 0, and this 0 would change this 6 to 0. So what would be the final matrix that would look like? So the final matrix should look like this: 0 2 0, and this should be 0 0 0, and this should be 0 0 0, because this 0 would make this row as 0, and this 0 would make this 0 as 0 row as 0. So now we can see that our 2 is intact by the change, because no element in this column changed our element in the first row. So that is intact, so that's why we can use this as our we can use the first row to store the columns, whether it should be 0 or not. But if we have a 0 in our first row, then we would set it as 0 at the very end. Suppose if this 6 was 0 here initially, then we have to make this 2 as 0 as well. So our final algorithm is that we would just check if our first row contains any 0. If it contains, then we would make it 0 at the very end, and then simply we would use this to store the columns, if that column should be 0 or not. So let's dry run this on an example. So we have 1 2 3, and I have a 0 6 8 and 9 4 and a 0 here. So we would start from the second row, and I would mark it as 0. Now very first, we know that the first row is a non-zero, so first row 0, here it is a boolean variable that would tell us that it is a non-zero, false. So we mark it as 0, and then we move to this, then we move to the next row, and this is non-zero, and this is a 0, so we mark it as 0. Cool. Now what we have to do is we would iterate through this matrix. So because we cannot change this first row right now, because we need it to manipulate the matrix further. So we have 0 2 0 and 0 6 8 and 9 4 0. So what we can do, we would iterate from the second row, and then I see that here it is non-zero, and this column should be a 0 because the first row has a 0 here, so we mark it as 0. And then this 9 should be a 0, and this is fine. Cool. And at the very end, what I would do, so our final array is 0 2 0 0 6 0 and 0 4 0 sorry, we can see that which is true. So this whole array was 1 2 and 3, so this 0 made this whole column as 0 here. And one thing that we missed is that we should make the whole row as 0, right? So we had to do this. We can do this here. So while marking those as zeros, so once we mark the column as 0, we make it as 0, and then we make it as 0 and 0. So this should be 0 0, And yeah, I might have made a mistake, but I hope that it is clear, and let's try to code it up. And in the code, I hope this would be more clear to you. So what I'm gonna do is matrix dot size int columns matrix 0 dot size. So first of all, we would take a boolean variable to store if the first row should be set to 0 not, and initially it is false, and we would iterate through the first row to check if it contains any 0. So if matrix of 0 call is 0, then we mark first row 0 as true. That means the first row should be 0 at the end in our final answer, and we break from it. Now what we have to do is we have to go from the second array, second row. So for int row and row plus plus, int column should be, sorry, yeah, so column is less than column plus plus. Now for every row we would check if it has a row has 0 false. So if by any chance, if our current element is 0, then we would say that it has a 0. And we also have to mark the column in the first row as 0, and also matrix of 0 and column mark it as 0. And then after iterating through this and marking the column as 0 in the first row, we would say if the row has 0, then set row to 0, matrix and row. This is a function that would set the row as 0. And then what we can do is we can set the other elements as zeros while iterating through the entire matrix. Now we would again for int column to 0 to column plus plus. Now we would use if our matrix of the first row column is 0, then current element should also be a 0. And we would do this, and then at the very end what we have to do is if our first row is a 0, it should be 0, then we say set row 0 matrix and 0. So we just have to write this set row 0 function, which would take our matrix and the row. So for int column 0 to column matrix 0 dot size plus plus, matrix of row and column should be 0. So let's try to submit it. Okay, so this worked, and I hope this is clear. And the space complexity is constant, big O of 1, and the time complexity is m cross n. We just reverse the matrix multiple times. Okay, thank you.